Is achieving net zero carbon emissions by 2050 a feasible goal or a far-fetched dream? That's the question on everyone's mind today. Western societies are in a full sprint to reach this seemingly elusive goal. The vision? A first-generation green power grid relying on renewable energy sources like wind turbines, solar panels, and power storage batteries. The objective is to phase out fossil fuel or nuclear power plants altogether. But that's not all. The grand plan also includes replacing the internal combustion engine with electric motors powered by lithium batteries. All these changes, the proponents argue, are not only achievable but also affordable, and they won't wreck the economy. Yet the path to this green future is riddled with obstacles. The most significant of these is the intermittent nature of renewable energy. The sun doesn't always shine, the wind doesn't always blow, and storing energy for use during these downtimes isn't quite there yet. And then there's the issue of scalability. Can we produce enough renewable energy to power our growing needs? Wind turbines and solar panels have a relatively short life cycle of about 20 years. Unlike fossil fuel or nuclear power plants, which can be retrofitted to extend their lifespans to 50 years, these renewable energy sources must be replaced entirely. Electric vehicles share the same fate. Once their useful life is over, they're destined for the scrap heap. Perhaps we should be calling these technologies replaceable rather than renewable. Because once their short economic lives are exhausted, they must be disposed of, often resulting in massive toxic dumps. So, is net zero carbon by 2050 achievable? It's a question that has sparked heated debate and will continue to do so. But as we move forward in our quest for a greener future, we must be mindful of the realities and challenges that lie ahead. We must ask ourselves whether the current trajectory is sustainable and whether the green solutions we're banking on are truly green. So let's delve into some hard facts. Let's examine the math and the science behind these bold claims and see if they add up. The truth, as they say, is in the numbers. Renewable energy and electric vehicles sound like the perfect solution, but what happens when they reach their life's end? Well, therein lies an often overlooked rub. You see, renewable energy technologies like wind turbines and solar panels have a surprisingly short life cycle of around 20 years. Yes, you heard it right, a mere 2 decades. Unlike their fossil fuel or nuclear counterparts, which can be retrofitted and extended up to a hearty 50 years, these green devices can't be given a new lease on life. And it's not just these renewable energy sources. Electric vehicles, powered by lithium batteries, follow the same fate. Once their engines run out of juice, they too must be scrapped. So you see, while the word renewable sounds promising, the term replaceable might be a more accurate descriptor. But what does replaceable mean in this context? Well, once these green technologies exhaust their relatively short economic lives, they need to be replaced, and the old ones? They are discarded, ending up in massive toxic dumps. It's like changing your phone every few years, except on a much larger and environmentally impactful scale. This reality brings us to an important question. Is the solution we're proposing for our environmental woes creating a different kind of problem? Are we merely exchanging one issue for another? These are questions that need serious consideration. So while we strive for a cleaner, greener world, we must also address the elephant in the room, the reality of renewable energy's life cycle and the subsequent disposal of these technologies. It's not as simple as swapping out the old with the new. The implications are far-reaching and complex, requiring a balanced view and comprehensive solutions. Now let's delve into some scientific research that brings a different perspective to the table. A recent study by the Geological Survey of Finland has some rather startling insights. It takes a deep dive into the feasibility of achieving net zero carbon emissions by 2050 and questions the adequacy of the current estimated metal reserves that are crucial to this endeavour. The study does not mince words. It states in no uncertain terms that our current reserves are woefully inadequate in almost every category. Moreover, mining these metals at current extraction rates would take centuries, making the 2050 target seem like an unrealistic dream. For instance, let's consider lithium, a key component of electric vehicle batteries that are touted as a cleaner alternative to fossil fuels. The study estimates that at the current rate, it would take close to 10,000 years to mine the required amount of lithium. An alarming number, isn't it? And then there's the question of base metals and rare earth metals, which are integral to the construction of renewable energy infrastructure. The study points out a significant shortfall in the reserves of these metals too. For instance, only about a fifth of the required copper and a tenth of the required nickel are currently available. But the challenges don't stop at extraction. These metals would need to be transported and processed, tasks that currently rely heavily on hydrocarbon-based fuels. This means more carbon emissions, further undermining the goal of net zero carbon. The study, conducted by Associate Professor Simon P. Michaud of geometallurgy, paints a sobering picture of the uphill task we face in achieving our green goals. His findings, available for you to peruse in a PowerPoint summary via a link in the description box, bring into sharp focus the gap between our renewable energy ambitions and the ground realities. In conclusion, the Geological Survey of Finland's study lays bare the monumental challenges in our path towards net zero carbon emissions. The numbers and facts present a reality check that is hard to ignore. As per this study, it seems like the journey to net zero carbon by 2050 is far more challenging than we thought. So what does all this mean for our net zero carbon goal? In the grand scheme of things, it seems we're stuck between a rock and a hard place. On one hand, we are racing to eliminate our carbon footprint, a noble and necessary goal. On the other, the green technologies we're leaning on, while promising, are not without their own set of challenges. We've delved into the reality of renewable energy, painting a picture that's far from the utopia the greenies have in mind. The lifespan of wind turbines and solar panels, the scarcity of essential minerals, the reliance on hydrocarbons for mining and transport, all these factors throw a wrench into the works. The hard truth is that the maths doesn't support the rhetoric. The potential risk of collapsing modern society is real if we hastily eliminate fossil fuels without a viable alternative. The net zero movement, while well-intentioned, needs a thorough re-evaluation. We invite you to share your thoughts and perspectives on this topic in the comments section. Let's keep this important discussion going.